Hi, this is Roger from Kanka Labs today with an already done teardown and a complete reverse engineering of a fake or a clone of the Hakko FX-951 solar station. Now the reason behind this is that David L. Jones a few weeks ago tested a new Vela soldering station in the $100 or euros region and compared it to his venerable Hakko FX-888, is it? Can't remember the exact number. And there was a reply from Louis Rossmann, which has a very recommendable YouTube channel, that it's better to buy for the same money a clone of the FX-951 than an original or genuine Vela or Hakko station in the $100 region. And his argument was that the classical cheap solder stations, they work with a heater element, or the connection of the heater element and the solder tip is just not very good, and that means they take a long time to heat up and they don't give reproducible results. Perhaps you might have seen the teardown and reverse engineering of the ATTEN AT-80D solder station, where I found a lot of problems, not only because of the, let's call it, non-optimal construction of the combination of the heater element and or the connection of the heater element and the solder tip, but also there were some faults in the electrical design of the circuit, etc. And so Louis Rossmann recommends better to have the cheapest station with these modern direct heated tips than any other station of the old type. Well, we'll discuss this thing later because I think it's really quite important. But first of all, let's take a look what you get. And every single piece that we talk of that you get delivered is really shit. That I can tell you beforehand. By the way, you can get this at AliExpress, for example, between $40 and $100 or euros delivered. I paid, including DHL Express delivery and including German VAT, less than 100 euros. So I think it was worth the experiment, because we lately upgraded our solder stations here to quite expensive JBC solder stations, and I thought this could be an addition if one of them breaks or we need a third solder place, etc. So let's start what you get. First is here the solder stand. Even the paint quality is bad. It already starts to flake off. You only get this sponge here, this water sponge, which is unusable. You don't get, as in the original Hakko FX-951, which costs around between 350 and 400 euros. You don't get the little container with the brass wool or brass mesh. Then the solder tip itself, it doesn't really fit here inside. And what lacks is the original stand has a little switch, so that when you put the solder iron into its stand, then it automatically goes into standby mode. Quite a nice feature. And if you buy the original Hakko stand alone, that costs around 50 euros. So this thing is really, you should get away with it. It doesn't really make fun to work with this. Next is the solder iron, of course, is also a copy, and it's so bad, the plastics is so bad. You can take these apart to change the front part to different colors. That the first time I tried to unclip this, the clips broke off. So this is really a piece of shit. I have no other word for that. Anyway, the replacement of the Chinese replacement just costs $10. So you should get one or two replacements beforehand. And even then, if you buy the original Hakko, iron holder or tip holder, that costs around 70 euros. So each single original part costs more than the whole station. The plug here, the strange DIN plug, you already can see, I don't know if you can see it here on camera, the two halves here of the metal shielding, they don't match each other, so also extremely bad quality. And Louis Rossmann even commented that although this should really clip into, but it doesn't. It doesn't stay. You can always draw it. I think that's not so important. Anyway, the cable is moderately flexible, so the flexibility is quite okay, but the plastic quality is really shit. So, what else have we got? Well, you get 5 tips delivered, and none of them is usable. You can, except perhaps for this one here. This is the only chisel tip that you get delivered, but it has 5mm size, so this is not for your universal soldering. And the other ones, you get 2 identical ones with a 45-degree angled cone tip. Well, this could be usable for drag soldering SMD parts, but they are really not what you want. And you get 2 conical tips that you can directly throw into the dustbin, because nobody solders with conical tips, and the only one that could remain is this one here. And for comparison, I have an original Hakko tip. You already can see the Chinese one says made in China, and you see the package is even different. This one here has the Hakko logo on it, and but if we really take them out, it's either they have, let me see, how do I get this one out? They look nearly identical, so it might be that this is really not a copy, but it has fallen off from the production line where Hakko lets them produce, although this cannot be. The Hakko one says made in Japan, and so I think this is at least a very good copy of the original Hakko ones. So anyway, you have to buy additional tips, at least 1 or 2 different chisel type tips, like this one here, which has around 2mm width of the chisel tip. Then what I really don't like with the Hakko is, first of all, this completely superfluous keycard. So you can change the temperature only if you put this little plastic clip inside. And the user interface of the Hakko is really the worst I have ever seen. What else do you get? This rubber mat. I even don't know how this looks like the original one. I don't know what it's used for and what it's good for. You get 4 rubber feet to glue them by yourself to the underside. They even don't fit very good, so nearly everything unusable. But my idea was, if we can at least use the main station and then upgrade it with some original Hakko parts, you are still cheaper than buying the complete Hakko set. You can get away with about half of the price. So now let's take a look at the electronics. But first of all, let's once again take a closer look at the tips. And there's one interesting thing. You can see you have 3 connections here, 2 rings, and here the main connection. But if we measure the resistance, we see that, hold on for a moment, that here the outer shielding is not connected to one, except for perhaps a 10 mega ohm resistor or resistance, whatever. So this is only the outer shielding which connects to ground, and that means that here between these two rings there has to be the heater element in series with the thermocouple. So that's the same principle as I found in the ATTEN station. I will link in down the videos with the reverse engineering of the ATTEN station down below. And the principle is okay. You have to do a little trick in electronics to be able, with only two connections at the same time, to heat the element, the solder tip, and to measure the temperature with the thermocouple in series. We will discuss this in a few minutes, but let's talk a little bit about the advantage of these so-called direct heated solder tips. The advantage is the heater element is in full contact with the tip, and that means it can heat up much faster, and the thermal resistance between the heater element and the tip is much lower than with the way it is done in the cheap stations or in the cheap solder irons. Here you have mainly only a kind of point contact, while here, because it's integrated, you have a full contact, and this should give a much better reproducibility and a much quicker heating time. So I agree with Louis Rossmann that you should change, if you upgrade your solder station, you should change to these modern direct heated tips. It doesn't have to be an expensive JBC or Thermaltronics or what other brands there are on the market. This is certainly an upgrade to the cheaper and older way how tips are heated. But now let's take a closer look at the electronics and what I found there. So let's take a closer look at the electronics and see if we can make use of that and how well it is built and engineered. What's quite okay is here the ISC connector and the nice little heat shrink tubing. That is quite okay. What I'm quite doubtful of, if this little transformer can really deliver 70 or 75 watts. It might be possible, but I haven't yet measured it, because at the moment I can't, because it's taken apart. I will measure this later and add the result, but I really can't imagine that this delivers really 70 watts full power. So this transformer has two windings. One is the 24, or they say 27 volts, that's probably without a load, and a 9 volt winding. And the 9 volt winding is simply for supplying the logic circuitry and the analog circuitry. And what else have we got? Here we see this is the connector for the tip, and you really can see the yellow line goes to protective earth or ground for the shielding or the metal casing of the tip, and these two wires connect here to the two little rings where heater element and thermocouple are combined. We have a little PTC fuse. That's quite nice. I don't know why Hakko uses a 1, 2, 3, 4, 5, 6, 7, 8 pin DIN connector. Probably they tried just to avoid faking, because this DIN connector is really hard to get, and it was probably the hardest thing for the Chinese to get the plugs and the connector copied. And so this is was it for the case, and now let's take a closer look at the PCB and the schematics I've reverse engineered. So this is one side of the PC. The solder quality is quite moderate. I've already cleaned a lot of it from the solder flux residue because otherwise I wouldn't have been able to take good photos and do the tracing. And you already can see here this opto-triac is not very straight sitting in. They didn't screw here the big triac down to the pad. There even isn't. They neither soldered it down nor did they. So what is this cooling area here for? If there is an air gap between that, so either you solder it down or there should be a hole and screw it down. And you see a lot of components are they are only not populated. There's a trace going through it, so there might be that there are two different versions available. It even looks like this thing can also be used as a dual station, because here would be the provision for a second triac. So Hakko also has a dual solder station, so it might be that this is a kind of universal PCB. The main controller is a Holtec HT46R24. The specs are it has 8K flash memory, 400 bytes RAM, 10-bit ADC, 4 PWM outputs, and an integrated I2 interface. So it's a it has less features than the classical Atmel AVR Atmegas or even the AT-Tinies. This little 10-turn trim pot is, we will see later, this is really necessary to trim out the errors in the analog circuitry. We have a little buzzer and a few electrolytics, and that's all. And so in here we can also see how the keycard works. Here we have a little light barrier consisting of an LED and a photodiode or photo transistor. And if you slide the other way around this plastic key inside, then the light beam is simply interrupted. So what's on the other side? We have our 7-segment LED, obviously multiplexed with, these are the driver transistors. We even have a quartz crystal, not a cheaper resonator. We have an I2C EEPROM. That's because the used Holtec controller, it doesn't have internal EEPROM, so they have to store the set values into the external EEPROM. 5-volt regulator, and this is the analog part here, with an LM358 dual op-amp. It even looks like it's a genuine TI chip. I've looked at it under a microscope and it doesn't seem to be a fake one. And take a close look here. They missed the soldering. This pin is loose from the triac, and just by chance it still has contact. And Louis Rossmann in his video, he even noticed, for example, they didn't clip off the leads here from the 7-segment LEDs. So a lot to be improved concerning the quality of the soldering, etc. And so, nothing more to say about this. Here you can also see a lot of unpopulated components, but really there's always a trace running through the component. And so now let's go over to the schematics and see what we can derive from that. So let's start with the analog part, because it's the more interesting one. This is the power part. We have first of all an opto-triac. It's the MOC 3023, and the internal LED is controlled or connected to a pin on the microcontroller. The upper half is with a 200 ohms resistor at plus 5 volt. And then there comes a part that I don't quite understand. So the gate of the triac, which in the end switches the 24 volt AC to the heater, to the solder iron, which is connected here at these two pins. The gate is controlled with the opto-triac, and the opto-triac connects it to one of the anodes. I'm not very familiar with triac control circuitry, but this looks a little bit strange. At first I thought I made a mistake in tracing, but I checked it twice and this is how it is really connected. Perhaps one of you can explain how this really works. Now you might wonder, how is it possible on the one side to drive the heater and at the same time to measure the output voltage of the integrated thermocouple? Well, you can't do it at the same time, but because the triac is controlled by the microcontroller, in each heating cycle it is turned off for a very short moment, and then this connection here is kind of hanging in the air. The lower connection here, where the other 24 volt AC connection is also connected to the analog circuit ground. So when the triac is turned off, we can measure the thermal voltage here, and this goes here to this RC combination. Now that also looks a little bit strange. This resistor here, that is simply an input current protection for the input of the op-amp, because when this thing is heating, then the full 20 volt AC are coming to the op-amp. Of course, much too much, because it is supplied as a single supply op-amp with only plus 5 volts. But I've written down some of the specs here. The input current has only to be limited to 50 milliamps, and if you do the math, at peak there are around 20 milliamps flowing here when the heater is turned on through R7 into the input of the op-amp, and then via the protection diodes to ground or to plus 5 volts. So R7 is simply a current limiting resistor to protect the input. But what an R5 and C1, they are building a little low pass filter. But what does R6 do, which is a 10K resistor connected to plus 5 volt? Well, this has to be part of the so-called cold junction compensation. You might know that a thermocouple can only measure relative voltages relative to ambient temperature. Now, we don't have an extra temperature sensor, neither here in the analog circuitry, nor is there one in the microcontroller. So we have to add a fixed voltage that corresponds to something like the average ambient temperature of, let's say, 22 degrees Celsius. And that's part of the circuitry, so you just add a little voltage here. It was done in a similar way in the ATTEN solder station, where they also simply added a fixed voltage which approximates the average ambient temperature in your lab. Then comes the first of the dual op-amp, which has an amplification of around 28. We have a little, this is the 10-turn trim pot, so the amplification is variable, and that is also mandatory, simply because the op-amp has an average offset of 2 millivolts. Now, if this is a type K thermocouple, 2 millivolts offset are equal to around plus minus 50 kelvins. So you have to have a way of, first of all, having a kind of offset compensation. And secondly, the scale factor. You cannot take the thermal voltage of around, I've written it down somewhere, I think here it's 42 microvolts per Kelvin. You cannot take this verbatim simply because there still is a little thermal resistance from the thermocouple to the tip, and therefore you must have a scale adjustment. And here is another addition of or subtractions. I still haven't figured out all the details, but also here plus 5 volt is somehow injected via a resistor to the amplification. So we have another protection diode here, and that is simply when the heater voltage is present here. The op-amp goes into positive saturation, and so that not here the second op-amp, you just save yourself the second current limiting resistor because the diode limits the output voltage to 0.6 volts, which is safe for the second op-amp. And this is simply an amplifier by a factor of 11 with another little low-pass filter by this 1 microfarad capacitor. And then we have an output voltage which is all in all amplified by a factor of around 300, depending on the setting of the trim port here. And this goes into the analog input of the microcontroller. So this is all the analog circuitry and only 2 connections to the microcontroller: the analog amplified temperature and the control of the optotriac, which in the end controls the main triac. So let's take a look at the digital circuitry. So this is all kind of standard as you would expect it. You have a single diode rectifier and 78 M055 5-volt regulator, the bypass capacitors, etc. This is the 3-digit 7-segment display with the anode. It are common anode displays with the 3 driver transistors, and the bases of the transistors are connected. Where is it here? To the microcontroller pins. The 7 segments plus the decimal point is also here connected. We have the 4 switches, we have the temperature input, we have the optotriac, here we have the buzzer, we have the I2C EEPROM, we have a reset circuitry. Strange, this is exactly according to the suggestion in the data sheet. But basically it's not necessary because this thing has a kind of brownout detection, so they could have saved these components. We have our quartz with the 222 picofarad capacitors, and here we have the little light barrier for the key card, excuse me, and that is all. And the interesting thing is this is a 28-pin microcontroller, and I'm planning, if I find the time, just to make a little adapter to desolder this and replace it with an Atmel 80 mega, I don't know, 328 or something like that, and to make my own firmware, because as I already told you, the user interface of the original Hakko station is really absolutely unusable. And what's also missing here, although they have 2 pins, 2 I/O pins left that could be made use of, we could connect one of them to the little switch in the solder iron holder, which has this switch for sleep mode. And anyway, I'm planning, if I find the time, to do my own firmware, not with the original Holtec chip, but with an 80 mega, where you only have to swap a few pins and then it can replace this thing nearly 1-to-1. So I think that was it, what I had to say about this circuitry. One thing also I don't understand. Look here, the current for the 7-segment displays is not, as it is usually done, limited with one resistor for each segment, but they have one common resistor to limit the total current. But that means that the brightness is different if you have only, let's say, only one decimal point lit, or if you have all segments lit, because then the current through R56 has to supply at maximum 8 digits, including the decimal point, while if there is only one segment or only the decimal point is lit, then it gets much more current than if all were lit. So did they really want to save a few resistors? I think this is again an example of bad engineering, as the Chinese, as in nearly every circuit I've analyzed from China, this is simply a design error. Or correct me if I'm wrong, if you have a better idea why they limit the current here at the emitter of the multiplex transistors. Don't know. Anyway, that was it. My final verdict is, what I would be interested in is, I couldn't find a schematic of the original Hakko FX-951 station. If anyone has reverse engineered or at least torn down an original Hakko FX-951 station to compare it if they did their own circuitry, or if this is really a copy of the original Hakko circuitry. Anyway, in my view, the price for the original Hakko station is totally overpriced. 350 or 400 euros plus tax. That is a factor of 2 overpriced for me. While with here I can at least use the basic circuitry, the transformer and the basic station, do my own firmware. I wouldn't have been happy with the original Hakko station simply because of the unusable user interface. So I would have to rewrite the firmware anyway so that I can work with that. And so I think it's really the better way, buying the cheap station, adding a few original Hakko components to it, which you can buy as spare parts, and then you have for half of the price a station that really works with the modern direct heated solder tips. So that was it for today. If you liked it, please give it a big thumbs up, and if you want me to do more teardowns or reverse engineering, you can of course support me on Patreon, or send me something interesting to take apart. And thanks for watching. Until next time, bye from Roger, bye from Kanka Labs.